topic 8, which is about acid, base, and salt, and which include the characteristic properties of the acid and the base. So we already discussed what are acids. Acids are proton donors, means any substance which donate proton, we call that as acid. Like example, HCl, when we write acid give proton, it give H plus and Cl minus. So because it is donating proton, so what we call this, we call that as acid. And if something accept proton, like example, if there was a reaction between HCl and NH3, as a result, when they react, it form Cl minus and NH4 plus. So when we check the change, first it is HCl, then it changed to Cl. So if the HCl turn into Cl, because it donate proton or it give proton, so as this HCl turn into Cl only, so it donate proton. So what we call this, we call that as acid. So acids are proton donors, and what are bases? Bases are proton acceptors. So as NH3 is written here, first it is NH3 and then it turned into NH3. Originally it is there and then it turned into NH4. So when NH3 turned into NH4, it means it accept proton. So whenever a substance accept proton, what we call that substance? We call that substance as a base. So acids are proton donors. Here HCl is an acid, where NH3, because it accept proton, it is acting like a base. Then we have already discussed the reactions of acid, the characteristic of acid. Like when acid react with metal, as a result it will form a salt and hydrogen gas. When acid react with metal oxide, it will form a salt solution and water. And acid react with metal hydroxide, that also result in a formation of salt and water. And acid plus metal carbonate, what will be the result? The result will be salt, water, and one more product is there, that is carbon dioxide, CO2 will be there. So describe the characteristic property of the base. What are bases as a reaction with acid and with ammonium salt, and what will be the effect on the litmus and methyl orange? So what is the base? Definition of the base: bases are proton acceptor or hydrogen ion acceptor, H plus ion. So any substance which accept proton, we call that as a base. So example, if we have the previous example, HCl was there and it is reacting with NH3. Then as a result, it turned into salt, ammonium chloride. So what will be the change? First it was NH3 and then it turned into NH4. So if NH3 turned into NH4, it means it accept proton or it take proton. So whenever a substance accept proton or take proton, what we call that substance? We call that as a base. And HCl is there, it turned into Cl only. So HCl turned into Cl, it means it donate proton or it donate H plus ion. So what we call this, we call that as acid. So acids are proton donors and bases are proton acceptor. And there is also another definition of a base, the substance which donate. So base is a proton acceptor, or we can also say OH ion donor. So if it accept proton or it donate OH ion, we also call that as base. So there are different examples of the base. So depending on, like example, we have NaOH. So NaOH is there, sodium hydroxide. When it dissolve, as a result, what happen? It will form Na plus and OH. minus. So a substance which is having OH or it is donating OH when it dissolves. So what we call that substance? We call that substance as a base. So sodium hydroxide is a base here. Same way potassium hydroxide KOH is there. It dissociates into K plus and OH minus. So as a result, what happened? Because it donate proton, so as it donate proton, donate hydroxide ion. So when it donate hydroxide ion or OH ion, what we call the substance? So we call this substance as a base. So base is having two definitions. Number one, either it donate OH ion or it accept proton. And whenever what is the characteristic of base? Whenever acid is reacting with the base, what is the result when acid is reacting with the base? It will result in a formation of salt and water. So acid plus base result in a formation of salt and water. This is one characteristic, that if you have any base, it reacted with acid, this will always result in a formation of salt and water. Example, we have hydrochloric acid. And it is reacting with sodium hydroxide. So hydrochloric acid plus sodium hydroxide, what will be the product whenever acid react with the base? So hydrochloric acid, this is acid here, and sodium hydroxide is a base. So whenever acid react with the base, what it result? It result in a formation of salt and water. So what will be the salt? If hydrochloric acid plus sodium hydroxide, so the salt will be, the first name of the salt is coming from the metal, and the second name is from acid. If it's a hydrochloric acid, it will form a chloride salt. If it is nitric acid, it will form nitrate salt. And if it is sulfuric acid, this will result in a formation of sulfate salt. So the product will be sodium chloride plus water. So the characteristic, one of the characteristic of base is whenever a base is reacting with acid, it will form a salt. That's the first characteristic of the base. It is also a characteristic of acid. When acid react with base, it forms salt and water. Or if a base reacted with acid, that will also result in a formation of salt and water. So if we have example, potassium hydroxide, and that is reacting with nitric acid. So potassium hydroxide plus nitric acid. Potassium hydroxide is a base. We can change the order, that does not make difference to the product. And nitric acid is there. So what will be the salt produced? Because potassium hydroxide, so the first name of the salt is coming from the metal, so that will be potassium. And the second name is from acid. If it is a nitric acid, this will result in a formation of nitrate salt. So potassium hydroxide plus nitric acid gives potassium nitrate plus water. Same way, if we have calcium hydroxide plus sulfuric acid. So calcium hydroxide is reacting with the sulfuric acid. What will be the salt form? The first name of the salt is from metal and the second name is from acid. So that's right, Abdullah. It is calcium sulfate plus water. So this is the first characteristic of the base. Number one, that whenever a base is reacting with an acid, this will result in a formation of salt and water. What is the second characteristic of base? That whenever base is reacting with ammonium salt, so ammonium salt plus base, what it gives, it will give another salt will be there plus ammonia gas. So this is the second characteristic of a base. Whenever a base is reacting with ammonium salt, what are ammonium salt? Ammonium salt means the salt which are having NH4. Those salt which are having NH4 are known as ammonium salt. Example, we have ammonium chloride and that is reacting with sodium hydroxide. Sodium hydroxide is NaOH. So when we react a base with ammonium salt, what it result or what will be the result? So this sodium, the metal, the base, the metal which is present in the base will take position of ammonium. So what it result? It will result in a formation of a salt, a new salt. So if ammonium is removed, NH4 is removed from here and sodium will take position. So what it result? It will result in a formation of sodium chloride, NaCl, plus ammonia. The formula for ammonia is NH3 plus water, which is H2O. So whenever ammonium salts are there, ammonium salt means the salt which are having this ion, NH4 ion. That's called ammonium ion. So those salts which are having ammonium ion, we call them as ammonium salts. As these ammonium salts are added to the base, the metal which is present in the base will take position of ammonium ion. So it will form a salt, a new salt will be formed, ammonia gas will be released, and there will be water molecule. So same thing, if I say in word equation, if I say we have ammonium chloride plus sodium hydroxide. So ammonium chloride plus sodium hydroxide. Now what will be the product? How we complete a product here? This base, because sodium hydroxide is a base and this is a ammonium salt, ammonium chloride. A salt means basically a compound which is having ammonium ion. These are salt, and because of ammonium ion we call them as ammonium salts. So what will be the result? The metal which is present in the base, like sodium metal is there in this example, it will take position of ammonia. So what will be the salt form when ammonium is replaced by metal sodium? So it will form sodium chloride plus, when ammonium is mixed with hydroxide, that is ammonium hydroxide, but this ammonium hydroxide is not a stable compound, it will form ammonia and water molecule. Is it clear, this example? Like what is a product when ammonium chloride is reacting with sodium hydroxide? Another example, if we have say ammonium nitrate and that is reacting with potassium hydroxide. So ammonium nitrate is reacting with potassium hydroxide. Now how to complete a product? So potassium hydroxide is a base and ammonium nitrate, that is an ammonium salt. So this potassium will take position of ammonium. So when this potassium will take position of ammonium, it will form potassium nitrate plus ammonium hydroxide is basically what it will form. It will form ammonia plus water molecule. So always this is a product whenever ammonium salts are mixed with base. So if we compare acid and base, when we are comparing acid with base, till this point what we have discussed, we are comparing. So acid, the definition of acid, they are proton donors. They donate H plus ion. What is a base? They accept H plus ion or donate OH ion. Then when we compare the characteristic, so first one, when acid is there, reacted with metal, this will result in a formation of salt and hydrogen. The second one, when acid is there, mixed with metal oxide, this will result in formation of salt, water, and when acid is there mixed with metal hydroxide, this will result in a formation of salt plus water. And the last characteristic, when acid is reacting with metal carbonate, this will result in a formation of salt, water, and there's another product which is carbon dioxide. So these are the products which are formed when acid is reacting with these substances. But what are the characteristics for base? So the characteristics of the base, whenever a base is there reacted with acid, if acid react with base or base react with acid, this will result in a formation of salt plus water. And whenever a base is there, mixed with ammonium salt, so this will result in a formation of a new salt plus ammonia plus water. So these are the characteristics which you have to learn for acid as well as base. Is it clear till this point? The comparison between acid and base. So acids are proton donors and bases are proton acceptor. Acid, they can react with metal, metal oxide, metal hydroxide, and metal carbonate. Whereas base can only react with acid and ammonium salts. Then what is the concept of strong acid and strong base, or weak acid and weak base? So the acid or base can be a strong acid or it can be a weak acid or weak base. What is the concept of strong acid? The term strong acid means the molecule break down into ions completely when mixed with water. And the concept of weak acid or weak base, the molecule break down partially when mixed with water. So example, we have a acid, say HCl, and we have 100 molecules of HCl in the beginning. And we take a container, we fill this container with water. So this container is filled with water, and what we do, we add this 100 molecules of HCl are added to this water. When we add 100 molecules of HCl into water, what we find majority of the molecule break down into H plus and Cl minus ions. And very few, like example, maybe one molecule is there which does not dissociate or break down, but most of the molecule dissociate into H plus and Cl minus. So if most of the molecule break down into ions when they dissolve in water or mix in water, what we call this acid, we call that as a strong acid. But what is the meaning of weak acid or weak base? Like example, if we have this ethanoic acid which is CH3COH and we have 100 molecules of ethanoic acid. But when we add this into a container which is filled with water, so as a result, what we will see when we add these 100 molecules of CH3COH into a container which is filled with water, we observe that most of them will remain as a molecule. Does not break down into ion, they remain as a molecule. So what we call, if it remain as a molecule when we mix with water, or most of them remain as a molecule when we mix with water, so what we call that as a weak. If it was an acid, we say weak acid. If it happened for a base, we call that as a weak base. So if it dissociate into ions, break down into ions, we call that as a strong acid, and strong acids have more ions. That's why strong acids are good electrolyte. Their solutions can conduct electricity. But weak acids, they are not a good electrolyte because they don't have charges or ions. Most of them are molecules, so they are not able to conduct electricity to greater extent. They can conduct, but not to greater extent. Is it clear? The difference between strong acid and strong base, or weak acid or weak base. So if a substance break down into molecule or the ions, we call that as a strong acid or strong base. If it does not dissociate or break down into ion, we call that as a weak acid or weak base. So example, you have a container, you fill with water, and you have NaOH, sodium hydroxide. And this sodium hydroxide you add, like you were having 100 molecule example. It can be any number, but I'm just taking 100 molecules are there of sodium hydroxide and you add them to water. And what you observe only one was remaining as a molecule, but most of them break down or dissociate into ions. So if most of them dissociate or break down into ions, what we say, is it a strong, because NaOH hydroxide, so means it is a base. But what kind of base is this? Strong or weak? What kind of base is sodium hydroxide? Most of them are ions, only one is there as a molecule. So it is a strong base because majority of them or most of them dissociate into ion. So whenever most of the molecule break down into ion when we mix in water or dissolve in water, we call that as a strong base. How I identify it is a base? Because there was OH ion, so it is a base. Then example, we have another container which is also filled with water. And we have calcium hydroxide. The calcium hydroxide, when we add this to water, so when we add this to water, like if we were having say 100 molecules of calcium hydroxide, what we observe only one molecule dissociate and rest all remain as calcium hydroxide, COH, like remain as a molecular state. Only one of the molecule dissociate or break down into ion. What we can say now? So what we can say about this, is it strong? Because it is OH is there or hydroxide, so we call that as base. But is it strong or weak? So how to identify? Because you can see majority of them, most of them are molecules and very few ions are there. So what we call that as a weak base. So weak base does not dissociate completely. Yeah, that's right. It's called a weak base. It does not dissociate completely. Whereas strong bases or strong acid, they ionize completely. Is it clear, the concept of strong and weak base? Then what are indicators? Indicators are normally solutions which are used to identify the nature of the substance. You have to learn this table, you have to memorize this table. If you have a blue litmus, then in acidic solution it is red, but in alkaline solution it is blue. If you have methyl orange, this is a name of indicator. You have to learn the name of indicator and its color in acidic or alkaline medium. So if you have methyl orange, it will be pink in acidic and it will be yellow in alkaline. If it is methyl red, it will be red in acidic and it will be yellow in alkaline. Phenolphthalein is there, which is colorless in acidic, and in alkaline it is pink. And if you have red litmus, it will be red in acidic, but in alkaline it will be blue. So these are the colors of indicator in different solutions. So you have to learn or memorize this table. Like as you can see, we add universal indicator or indicator on the left hand side. So it appeared to be pink. So this pink color, originally this was colorless because acid and alkalis are colorless. But when we add indicator, indicators show a color change when it is added. So when we add an indicator, you can see it is red or pink. So it shows this is acid and this one is alkali. There are different types of indicator. Universal indicator is also one of them. So whenever, as you can see, when we add universal indicator, it's a strong acid ionized completely, whereas weak acid ionized partially. So what happened in the beginning here, first when we add an indicator, this on the left hand side we have acidic solution. So this solution is acidic. When we stir thoroughly, it mix. Why we are wearing a gloves here? Because acid and alkalis are corrosive. That's why you are using a glove. And when we add universal indicator to the right hand side container, so it shows a color blue or purple in color, which show a base or alkaline. But when we mix the two solutions, you see the color disappear. Why the color disappear? Because when acid and alkali are mixed together, they neutralize each other, they cancel out the effect of each other. That is why the color disappeared. So acids are substances which give H plus ion, bases are, or alkalis are substances which give OH ion. What is the difference between base and alkali? There's only small differences there. The statement all bases are alkalis all alkalis are bases, but all bases are not alkalis. What is the meaning of this statement? Example, if you have sodium hydroxide is solid at room temperature, NaOH is solid. Because it is hydroxide, whenever hydroxide is there, what we call this substance, we call that as a base. We take a container, we fill this container with water. So we fill this container with water, and what we did, we add this base to water. So when we add this base to water, if it dissolves, if base dissolve or disappear, what we call that as alkali. So sodium hydroxide is a base as well as alkali. But what happened? Example, you have magnesium hydroxide or calcium hydroxide. Calcium hydroxide is also a solid at room temperature because it is a hydroxide, so it means it will be a base. You take a container and that container is filled with water and you transfer that base into water, like you add that base to water, and what you observe, what you see that the base does not mix with water, it remain as it is. So if that base does not mix with water, so we don't say like it is insoluble in water, does not dissolve in water. So if it is insoluble in water, what we simply call, we only call that as a base. So all alkalis are bases, but all bases are not alkalis. Like base, some of the bases can dissolve and some of the bases cannot dissolve. So base which can dissolve, so soluble base, soluble means it dissolves, so we call them as alkali. But if we have insoluble base, insoluble means does not dissolve in water, so insoluble base is simply known as base. We don't call that as alkali. Is it clear? The difference between the alkali and the base? So base means a substance which contain hydroxide ion or they accept proton or even oxide. We call them as base. But if it dissolve in water, if it mix in water, we call them as alkali as well. We can say base or we can say alkali. But if it does not mix with water, we simply call them as base. Is it clear, this example? Sorry. Is it clear, the concept of the base? So there's also another way to identify the nature of the solution. We can use a scale which is known as a pH scale. That pH scale ranges from 0 to 14. The smallest value is 0 and the maximum value is 14. Less than 0, anything which is less than 0 is known as, less than 7 is known as acidic. More than 7 is known as basic, and equal to 7 is refers to neutral. So when pH is equal to 7, it is neutral, less than 7 acidic, more than 7 alkaline. So example, if we have a pH 4, what is this substance? Acidic, alkaline, or neutral? Or we can also say basic. Instead of alkaline, we can also use the term basic. So a pH 4, it is acidic because it is less than 7. If we have pH 11, so it will be basic or alkaline. And if we have pH 7, it means the substance is a neutral. So this is also another way to identify the nature of the solution, is by measuring the pH. And strong acid, when we have a strong acid, they have a lower pH. For example, pH 1, 2, these are the strong acids. pH 3 to pH 6, these are acids but weak acid. And 12 to 14, these are refers to strong base. And from 8 to 11, these are refers to, so alkali can be strong or weak. So if it is pH 12, 13, 14, it means that is refers to strong. If pH 8, 9, 10, 11, that is refers to weak. If pH 0, 1, 2, that is strong acid. And pH 3, 4, 5, 6, that is refers to weak acid. So you should be able to identify, like sometime you have to predict the pH. They mentioned it's a weak acid, so predict the pH. So how you can predict the pH? So from 3 to 6, you can tell any number. These answers have range, not a fixed number. So you can mention pH 4 is a weak acid. Same thing, pH 1 is a strong acid. Another thing, if we have a weak base or alkali, we can say pH 9 or 10. Or we have a strong base or alkali, we can say pH 13 or 14. So using the pH scale, we can also identify the nature of acid and alkali. Is it clear, this part? The reaction, the first we started with a characteristic of acid. Acids are proton donors, then bases are proton acceptor. Acids, their characteristic as well as base.